So before further starting with PNC previous year questions, first let's have a quick recap of the chapter. Okay, there's nothing much to discuss. Simple n factorial is n into n minus 1 into n minus 2. Simply 2 till it becomes 1. Okay, so n factorial can also be written as n into n minus of 1 factorial. Okay, nice. And what else? If we have to find out the total number of permutations, that is, if we have to find out total number of arrangements that we can do with R number of elements out of n, then we'll simply solve the particular number of ways by using this formula. And if we have to, in this particular case, we were selecting R elements from n and then we were arranging them, interarranging them. In this condition, we are only about when we'll solve for combinations, we'll only be calculating the number of selections, the number of ways to make R selections out of n things. So these are 4 formulas. Okay. And so let's talk about some concepts of geometry now. Let us say there are certain points given to us. Let's consider that 1, 2, 3, 4. There are 4 points. In how many ways we can make a straight line? Like how many straight lines can be made? For any straight line, we know 2 points are required. So if there are 4 points given, we'll have to select 2 points out of them. We will select 2 points out of 4. So and the number of ways in which we can do so will be the number of straight lines that we can make. Like if I select these 2 points, that's one method. So there will be one straight line. If I select, let's name these points. If I select P1 and P3, then this is another straight line. So with each and every selection of 2 particular points, we'll have a different straight line. So number of ways to select 2 points is equal to number of straight lines possible. Is everyone clear with this particular statement? Yes?
Yes, sir.
Okay. So for finding about the number of ways to select R element out of n, we used to write NCR. So similarly, we can write here 4C2 will be the total number of straight lines, which is 6. Let's solve it by using formula 4 factorial, 4 minus 2, that is 2 factorial, 4 minus 2, sorry, 2 factorial. Okay. 2 cancels 4 factorial by 12 because 24 by 2 becomes 12. 12 by 2 becomes 6. That's why there will be 6 straight lines. There are 6 straight lines possible. Okay. So let's find out. This is 1. Okay. 1 straight line. This is 2. 3 straight line. 4 straight line. 5 straight line. 6 straight lines. That is how. So from here, we can conclude that number of straight lines drawn within n points is selection of 2 points out of those n points. Simple. Now, in the number of ways we can select 2 points, so that will be your number straight line. Cool, cool. So in previous question, we have taken 4 points, out of which we had made 4 straight lines. But if we will observe this shape, this is a quadrilateral. Now here, in a quadrilateral, there are 4 sides. We know number of points is equals to the number of sides they are going to have, and how many diagonals? Plus 2 diagonals. So if we break this down, that NC2 was number of straight lines, and total straight lines were including the side of the polygon plus the number of diagonals of the polygon. Okay, I should have written number of sides of polygon and number of diagonals of polygon. Where n is number of vertices. Okay, and if that is so, we are very much aware that the vertices is has to be equal to number of sides of polygon. Like 4 points are there, 4 vertices are there, then definitely there will be 4 sides. Okay, so this is going to be equal to n only. So nc2 is equals to n plus number of diagonals. Because if we have 3 points, then how many sides will be there? 3 sides. If we have, let's say, 5 vertices, so how many sides will be there? 5 vertices. 1, 2, 3, 4, 5. 5 sides will be there. So hence we can conclude that number of vertices is equal to the number of side of the particular given polygon. So number of diagonals of polygon having n vertices. So if we have to find out the number of diagonals of a polygon with n number of vertices, then we may write nc2 minus of n. Now this is a really very important formula. In questions, previous year questions has been asked on this particular formula multiple times. Are you able to understand that how this formula originates? Is that clear, everyone? Isn't it? Please read. Hello, hello. This is important, really important for your class, for your ND exam coming in 100 days. Yes, sir. Yes. So these are the we were talking about quick recap. Okay. So we have discussed about the number of sides, number of diagonals that are there. Okay. I have one more concept from geometry. There are circles. Okay. And now we will discuss about the intersecting points of circle. Okay. Uh, so let's say if there is like to find out the intersecting point, we have to have at least 2 circles. That is for sure. Okay. So 2 circles intersect on how many points? Except we will not be taking the case of coincident circles. Coincident circles means one circle and another circle is also lying on the same circumference. We are not going to consider that scenario. Okay? Otherwise, we will have infinite, in this case of coincidence, we'll have infinite point of intersection. But normally when there are 2 circles, uh, which are not collapsing each other, which are not coinciding with each other, 2 circles. So how many intersecting points are there? 1 and 2. Okay. So we'll write here number of intersecting points. Okay. So how many are there? 2. How about 3 circles? 1, 2, 3, and 4. 4 intersecting points. So now we from the first, like let's call it circle 1 and circle 2. Let's call it circle 1, circle 2, circle 3. Now, from the first case, we may conclude that with every two circle intersecting each other will have definitely two intersecting points. Using the same analogy, here in this case of second, okay, uh, let's have some space. We know two circles, when they will be intersecting, they will have two intersecting points. So C1 and C2 will have two intersecting points, and C2 circle intersecting with C3 will also have two intersecting points. C1 and C3 will also have two intersecting points. Okay, so what is the basic, what is the fundamental that we can conclude here? That with every two circle intersecting with each other, there will be two intersecting points. Okay, cool. Now, if we have n number of circles, okay, we have n number of circles. So we knew one thing for sure. For every two pair of a circle, we are going to have two intersecting points. Okay. Now we have to just find out how many pairs of circles we can have. Earlier we had C1, C2, C2, C3, C3, C1, C3. So basically, we have to find a pair. Okay. Now, for that, how many options were available for 3? There were, let me write here only. How many options were there? There were 3 circles. So, 3 options were there. Having used one circle, now we are left with 2 circles to fill in choice, because we cannot repeat the same circle because we are finding the intersection with other point. So, 6 number of cases here. 6 pairs is that we can find, and with every pair there will be 2 intersecting points. So we will multiply 2 also here. So it will make it as, sorry, as are we missing on something? C1, C2. How we have 3 choices here. Having used one choice, we are left with 6. Okay, 6 into 2 will become 12. And also, one more thing is to consider, that in this particular case, pairs are going to repeat. Okay, so you do not need to take their arrangement in consideration. So we'll divide it by 2 factorial. Okay, so here we can conclude that how many pairs we can select out of n circles. So we have to select 2, and with every pair there will be 2 point of intersection. So this comes out as a formula of number of intersecting points among n circles, okay, among n circles given to us. So that's an important formula, and the previous year questions has been asked on this same concept on, if I remember rightly, in 2020, I guess. This is the formula. With every pair you will have 2. Now let's take an example of the same. I have its example somewhere. Yeah. So what is the, in this question we have to find out what is the maximum number of points of intersection of 5 known overlapping circles. Okay. So we have to select 5 C2. These many pairs we can make. With every pair there will be 2 intersecting points. So 2 into 5 factorial divided by 5 minus 2, 3 factorial into 2 factorial. 2 cancels 2. 5 by 3. 5 factorial divided by 3. 5 into 4 into 3 factorial upon 3 factorial. 3 factorial cancels 3 factorial, 20. So there will be 20 number of points of intersection of 5 known overlapping circles. Are you able to understand it? Is there any doubt?
Yes, sir. No, no, sir.
Okay, I was confused. Anyways, so that's how the question is going to come. The formula is going to get derived. That is the logic. And if you don't even remember the logic, at least remember this one. Okay. And if there is any doubt in the logic, please ask. We will clarify and discuss further.
Sure, sir.
Okay. So let's now talk about another concept. See, whatever concepts I am talking today, teaching today, are strictly based on previous year questions. Triangles. So we can make triangle with 3 non-collinear points. Simple. Why non-collinear points? What are collinear points? Collinear points are those points which can lie on a straight line. Let's say this is a straight line, and if I take a point here, another point here, another point here. So these are 3 points lying on a same straight line. So these are collinear points. And as you can see, there is no triangle can be formed using this. If we have taken another point that is not there on the straight line, so P1, P2, and P3 and P4. So using any 3 points here, and P4 is compulsory to consider out of these 4, because if we will take these 3, then there will be collinear points. If we consider just P1, P2, and P4, there we have a possibility to make a straight line, to make a triangle. Okay, like this. This is a triangle, right? So we cannot make triangle with collinear points. That's the only point to consider. Anyways, so let's come to the point. So to make triangles, you have to select 3 points, and in whichever way you will be possibly able to select 3 points out of n points, then you will be able to make these many number of triangles. Now remember, while selecting, points do not have to be, all 3 points do not have to be collinear. Okay, these 3 selected points must not be collinear. Is there any doubt, anyone? No?
No, sir.
Okay. Now we shall move ahead with the question now. Okay. So this is a given concept that we have talked already about. What is the number of diagonals of an octagon? So what is an octagon? Can anyone tell me? Anyone?
The shape with 8 sides.
Yes.
Polygon.
Yes. What is a polygon?
Is it a closed figure with many sides or?
Yes. Yes. Two-dimensional closed figure. What is the polygon which is having least number of sides?
Triangle.
Yes. And which is the polygon having no number of sides? Like infinite number of sides, you can say, or may say 0 number of sides. Whose number of sides is not defined? Which is that polygon?
Line.
Hmm?
No, I think so.
No, line is not a closed figure, na? Line is not.
That's why. So I don't know.
Oh, this is the way, right? How many number of sides do a circle have? No, right? So that's
Just
something weak. Okay. Triangle have three number of sides. Square have four number of side. Pentagon have five number of side. Hexagon have six number of side. And then comes hept, right? If I'm wrong, please correct me. Then comes O, and then comes known, a nine, and then comes tech. Chemistry. Finally helping somewhere. Then comes tech. Okay. Is that clear, everyone?
sir.
Yes. So let's go to the question. Question is asking that the number of diagonals of an octagon. We have already discussed about the formula of C, which is NC of 2 minus of n. The reason I have discussed earlier. So the number of sides of an octagon is in 8. 8C2 minus 8. 8 factorial, 8 minus 2, that is 6 factorial multiplied by 2 factorial minus of 8. Now, this will expand as 8 into 7 into 6 factorial. 6 factorial, 6 factorial cancels each other. 2 factorial is 2. So 2 4 is 8. 4 7 is 28 minus 8. That should be 20. D is your correct answer. Any doubt, anyone?
No, sir.
This is how easy it is. Basically, we have find out the total number of straight lines that we can form in using 8 points. And then after that, we have excluded the number of sides. And then we will have the diagonals as our resultant. Clear? Number of straight lines using 8 points. And these are number of sides of octagon. What is left is number of diagonals. We have applied the same formula. Okay, next question is if P or now C and PR can also be written as P of N and R like this. And same goes for CR also. C and R. Now it is given that NPR is 2520. NCR is 21. We know the ratio of them will give us R factorial because of their formula. Are you aware that NPR is n factorial upon n minus of R factorial, and this is n factorial upon n minus of R factorial into R factorial. So that's why their division will give us R factorial. Clear?
Yes, sir.
Yes. Now let's divide. 21 ones are 21. Have 25 minus 21, 4, 2, 42, 21 2s are 42, 1 0 left. So 120 is equals to R factorial. 120 is what? 5 factorial. So R is what? What is R? R comes out as 5. Okay. Now we know NC of, sorry, NC of R is given as 21. We have found out just that KR is 5. Now it is given as 21. Now let's expand it using the formula on the next page. N upon n minus 5 factorial into 5 factorial is 21. Nice. So it's going to cancel, like expand n minus 1, n minus 2, n minus 3, n minus 4, n minus 5 factorial is going to get cancelled with the denominator. And let's write 5 factorial. 2 on to the right hand side getting multiplied with 21. 5 factorial is 120. So that's why I have written the same. Let's cancel this. Clear? So let's just eliminate the distraction. That's a long calculation. Now the multiple of, okay, so it would be better if we can somehow prime factorize this and try to find out such same numbers instead of solving this big calculation. So let's try to simplify. 21 can be written as 3 into 7 into 120 can be written as 2 into 60, 2 into 30, 2 into 15, 3 into 5. Okay, cool, cool. So let's write how many consecutive numbers are there? 1, 2, 3, 4, 5. 5 consecutive numbers should be there. Okay, okay. So one will be definitely 7. And another one can be 3 into 3, 9, which is close to 7. So 7 and then 9 and then 8 should also be there. So for making 8, 2 into 2 into 2, this will make us 8. What is left is 5. Now there is another integer left, 6. Okay, we have already used this, right? We have already used these twos. Have I written 120's prime factors rightly? 2 into 60 is left. Now 30 is left. Now 15 is left. 8 into 15 is 120. Okay, I was right. 3 into 7. Okay. So we cannot make 6 now, right? We have already used 3, 3, 7, 7, 5. Okay. Have we done any mistake? Have we done any mistake? R is 5. Okay, rightly mentioned. Now NC of 5 is 21. Okay, so let's assume that n is 5 here because of here something will happen and the least prime factor is 5 here. So let's try to assume that n is 5, whether we'll be getting n 5c of 5 as 21. No chance it will become 1. Okay, so let's assume n is 6, but the least is n minus 4. So we had to assume n minus 4 as 5, right? The least is 5 here on the right hand side. The least on the left hand side is n minus 4. So n should be 9 as per our assumption here. We are hitting and trying. So 9c of 5 should be 9 in 9 factorial upon 4 factorial to 5 factorial. It will cancel it as 9, 8, 7, 6. Okay, 4 factorial is what? Basically 24. 6 into 4, this becomes 2. 9, 18, 7 ja. 18, 7 ja. Anyone? 126, which is not equal to the right hand side. Let's take n minus of 4 as 6, 10. N is equals to 10. Now let's try to find out 10c of 5 is what? 10 factorial divided by 5 factorial into 5 factorial. This cancels this by 10 into 9, 8, 7, 6, not 5. 5 factorial is basically 120. 0 cancels 0. Now 6 cancels 12 by 2. This cancels by 4. 36 into 7. 36 into 7. 7 6 of 42. 7 3 of okay, 252. This has some chance to be equal. 2400, 120, 2400, 2520. Yes. We have it equal. So our assumption for n is equals to 10 was right. So basically in calculations like these, we have to make assumptions. Are you getting my point key how we have done so? Or should I repeat?
So could you repeat it?
Okay. Basically, after seeing that the equation is becoming 5 degree, I dropped the idea of factorizing by conventional method of algebra. Now I started observing numbers and looking for factors on the right hand side so that we can equate situations. Okay, let it get erased first. So I hope this is clear till now. N minus 2 and minus of 3. Okay, great. Let me re-explain that NPR was given to us, NCR was given. NPR upon NCR is basically going to become R factorial. So R factorial was equals to 120. 5 factorial is equals to 120 as we are aware. 5, 4, 3, 2, 1. Okay. 20 into 6 is 120. That's why R is 5 here. Okay. We have pointed out R's value and it was given to us that NCR was 21. So NCR is 5 here. So NC5 will be 21. So let's solve for the formula n factorial upon n minus 5 factorial into 5 factorial. 21 into 5 factorial basically 21 into 120. Okay, nice. Basically, we can also write 120 because this is 5 factorial. So let's expand 5 factorial itself. 5 into 4 into 3 into 2 and into 1. 1 that is doesn't matter. And here n factorial expand n minus 1 n into n minus 1 n minus 2 n minus 3 n minus 4 into n minus 5 factorial, which will get cancelled with the denominator. Let me do that also. Into n minus 5 factorial equal to, and what was there in the denominator, n minus 5 factorial into 5 factorial that has gone to the right hand side. This and this will cancel each other. Is that clear? So to clear this mess, I'm just going to erase them. Okay. Now let's try to make factors on the right hand side with numbers who are consecutive. So whatever n is going to become here, that will be an integer. Okay. So if we subtract 1 from that integer, the integer that was just behind is going to come. Another time if we subtract 2, so it will come the integer that is like basically 5, 4, 3, 2, 1. So assuming n is 5 here, so this is n minus 1, this is n minus 2, this is n minus 3, this is n minus 4. So that's what we are writing here. Okay, but we cannot equal n minus n is 5 because 21 is also here. So 21's prime factorization is 3 into 7. Okay, now we'll have to make some consecutive numbers, and how many? 1, 2, 3, 4, 5. 5 consecutive numbers should be there. Let's write 1 also for our convenience of understanding. So 7 is a prime number, and we cannot break that further down. Okay, 7 cannot be broken down into further. So, and assuming that 7 is the biggest number here, so let's write, and 7 is not the biggest, and like 5 into 2 can be written also, and 10 can be written, 5 into 4 20 can be written, but we have to write consecutive numbers. So let's try doing something. So we can start making with 1. So if we will make with 1, so what will come? 1, 2, 3, 4, and 5 should come. But if we do so, 21 is left. So we can start with 2 and we can ignore 1. 2, 3, 4, 5, and 6. But 7 will be left then. Okay. So let's ignore 2 then. And let's try to make it 3, 4, 5, 6, 7. Okay. In this case, what happens? Are we able to do this? So 3, 4, 5, and 6, and 7. Cool. We are able to do it. So 7 is the biggest number here. 7 is the biggest number here. Okay. So if 7 is the biggest number here, n should be equal to 7. Okay, n should be equal to 7. Let's hit and try and check whether n is equals to 7. N is equals to 7 or not. 7c5 has to be 21 if that is so. 7 factorial divided by 7 minus 5, that is 2 factorial into 5 factorial. Now this cancels it by 7 into 6 into 5 factorial. 5 factorial gets cancelled with the denominator. 2 cancels 6 by 3, this is 20. Yes. So with n being 7, the question can also be solved. And I have just explained that how I have assumed and how have I assumed that n can be 7 using this analogy and basic observation. Is that clear, everyone, that n can be 7? Yes or no?
Yes, sir.
Okay, cool. So let's now find out the answer with n being 7. R was 5, n is 7. Now we have to find out n plus 1. So 8c of r plus 5 plus 1, 6. 8 factorial divided by 8 minus 6, 2 factorial into 6 factorial. This cancels it by 8 into 7. 2 cancels 8 by 4. 4 into 7 is 28. C is the correct answer. Okay. Understood? Is that clear, everyone? And yes, n was coming as 10 earlier because we were equating it equal to this particular value here. Okay, that is why. And 5 factorial was down here. ठीक है इसलिए आ रहा था n by this. Is the question clear now? Or still is there, if there is any doubt, please ask. I'll explain it again. Is there any doubt? No? Okay, then let's move ahead. This is the correct answer. Now, we remember the properties of NCR, n plus 1, NCR. Okay, so that's the property that is going to be applied here, applicable here. Otherwise, you can also solve their particular values, but it will take a hell lot of time. You will have to solve for this, and after solving all the values, you will add, and then you will solve all the values of options, then you will match. It's going to take a lot of time, so it's better to remember the properties. 47c4 plus 51c3 plus 50c3 plus 49c3 plus 48c3 plus 47c3. Now observe one thing. This property is applicable on only having combinations same number of combinations having same number of n. Where are they? In the first and in the second. In the first and second term. So these. So the n's value is going to get added 48 and r will is going to remain whichever the greatest was. 4 is the greatest. 48c8c4. This has these two terms now has become added and the sum is this plus 51c3 plus 50c3 plus 49c3 plus 48c3. Now n is same among these two terms. Okay. And r is 4 here, the greatest. 48 plus 1, 49, c4 is the sum of both of these terms and whatever, there was remaining. 48 plus 1, 49, c4 is the sum of both of these terms and whatever there was remaining. 48 plus 1, 49, c4 is the sum of both of these terms and whatever there was remaining. 48 plus 1, 49, c4 is the sum of both of these terms and whatever there was remaining. 48 plus 1, 49, c4 is the sum of both of these terms and whatever there was remaining. 48 plus 1, 49, c4 is the sum of both of these terms and whatever there was remaining. 48 plus 1, 49, c4 is the sum of both of these terms and whatever there was remaining. 48 plus 1, 49, c4 is the sum of both of these terms and whatever there was remaining. 48 plus 1, 49, c4 is the sum of both of these terms and whatever there was remaining. 48 plus 1, 49, c4 is the sum of both of these terms and whatever there was remaining. 48 plus 1, 49, c4 is the sum of both of these terms and whatever there was remaining. 48 plus 1, 49, c4 Conveniently here also on the in the last two terms n is same. So n plus 1, 49 plus 1 c, and the r which is the greatest 4 plus 51 c3 plus 50 c3, and that's already added. Now the last two terms also have n here, n common here, and r with the difference of 1. Okay, so their sum is going to become 50 plus 1, 51, and r, which is the greatest ones, 4 plus 51, c3. Coincidentally, n is also same here with the last two terms, 51, 51 plus 51 plus 1 becomes 52. C, r with the r, whichever is the greatest out of two, 4. 52 C4 should be our answer. C option. Any doubts, anyone? Any doubts?
Sir.
No doubts. Like this. See, the property is very important here. They have also represented it well. So NCR plus NCR minus 1. So basically n is common here then only the property will be applicable. And then n is going to get added with 1, and r, whichever was the greatest out of 2, that will be used. And similarly, here also with 48, they have written it wrong. Okay, they have arranged it. Okay, so 48 is common. So it will become 49, and with 4 the greatest. Okay, 4 here. Similarly, the property is becoming applicable with every next step. Okay, so question is given like this: 20c of n plus 2 is equals to 20c of n minus of 2. We have to solve for the single variable that is present in the equation. That is going to be very easy for us. But the calculations are going to be a little typical. Applying the formula 20 factorial divided by 20 minus of n minus of 2. 20 minus n minus of 2 factorial into n plus 2 factorial is equal to 20 factorial upon 20 minus of n minus of minus becomes plus 2 into n minus of 2 factorial. 20 cancels 20. Let's cross multiply, and okay, 20 minus of n plus 2 factorial into n minus of 2 factorial is equals to 20 minus n minus of 2 factorial into n plus 2 factorial. Let's expand them on the next page. Okay, we can now observe on the both sides that if we are going to expand n plus 2 factorial, then n minus 2 will be there. If we are going to expand 20 minus n plus 2 factorial, then 20 in one of the forms when we will be expanding its factorial, there will be one such term which will be equal to this one. So we'll do accordingly. We'll expand the greater factorial. Okay, so 20 first let's solve them. That will be easy for us to understand. 20 plus 2 becomes 22 minus of n factorial into n minus of 2 factorial is equals to 20 minus 2, basically 18 minus n factorial into n plus 2 factorial. Now let's expand the greater ones. So 21 minus n, 22 minus n into 22 minus 1, that is 21 minus n. 21 minus 1, so 20 minus n into 19 minus of n into 18 minus of n factorial. Now this this factorial is applicable on this term only. Okay, keep this thing into n minus 2 factorial will not touch this. Writing the right hand side onto the next line. So 18 minus factorial will not touch this. We'll expand the second factorial, n plus 2 into n plus 1 into n minus of 1, n minus of 2 factorial. We'll stop here because it's equivalent to some term in the left hand side. This and this cancels each other. 18 minus n factorial cancels 18 minus of n factorial. What is left is this 22 minus of n into 21 minus of n into 20 minus n to 19 minus n is equals to n plus 2. Let's write n minus 1 first to n plus 1 to n plus 2. Four terms, four consecutive integers on the right hand side and four consecutive integers on the left hand side. The variable is the same. Okay, nice scheme, nice scheme. Now we have to look for the options. We'll have to hit and try from the option because this time the options are clearly given to us. So looking at the options, looking at the terms here, we are able to somewhat make that particular number should be around 20 in between 20 in between somewhat. So there are four consecutive terms on the left hand side, four consecutive terms on the right hand side. So that number should be around in tens, like 10k for this side, to this side, or to this side, or one this side, or to that side. Somewhat like this. Because of the feel that we are getting after reading the numbers. So let's now start with which option. Anyone can tell me which option should we start from? Hitting in trialing, trying. Anyone? Which option we should start from? Someone have any idea? Okay, so I'll have to start from A only. A is equals to 18. Okay, so n becoming 18 as per the A option. So 22 minus 18, 4. 21 minus 18, 3. 20 minus 18, 2. 18 minus, sorry, 19 minus 18, 1 is equals to n minus 1, that is 17 into 18 into 19 into 20. Oh, that's not happening. We can clearly see here. Okay. And this becomes 3. So 1 is not equals to definitely 17 into 3 into 19. Okay, A option is the incorrect answer. So it's eliminated. Let's take option number B. That is clearly not possible. If you take anything greater than 22, like 25 is there. So if we take n is equals to 25, then product is going to become is going to become negative. If we write 25 here, this will be negative, this will be negative, and that can definitely not exist. Why so? We can also see here, if we write 25 here now, so it will become 27, and 27 does not exist because r cannot be greater than n. That's just situation. It cannot happen. Let's take, so B is also an incorrect option. Let's take option number C then. Okay. Now considering option number n is equals to 10 as per option number C. 22 minus 10, that will be 12. 21 minus of 10, that will make it 11, 10 into 9, basically 4 consecutive integers. Decreasing order, yes. N minus of 1, 9 into 10 into 11 into 12. Now, yes, 9 is there, 10 is there, 11 is there, 12 is there. 1 is equals to 1. Yes, definitely. Option number C is the correct answer. So by hitting and trying, we are able to find out the correct answer. Is there any doubt, anyone?
Sir,
No doubts. Great, cool. Let's solve this question. What is the number of ways in which the letters of the word able can be arranged so that vowels can occupy even places? First, let's talk about places. So we have four letters A, B, L, E, and we have to make use of the all the letters of the word to make words. So there are four places. How many even places? This is second place, this is fourth place. So these are two even places. And we have to make a certain situation where vowels will only occupy. How many vowels are here? Can anyone tell how many vowels are there here? Which one?
2.
Yes, A and E. So how many options to fill the second position?
2.
Two vowels are there. Having used one vowel, how many options we have here? One option. Now, please observe this fact that I am first placing those letters on which condition, special condition is applied. Thereafter, I'll consider other places because they are not so special. Okay, so having already used two letters, how many options we have? Two. How many options for this place? One. They are all independent events. So 2 into 2 into 1 into 1. 4 should be the answer. Is that clear, everyone?
Yes, sir.
Nice. Let's check the answer. Yes. 4 is the answer. Second and fourth place are even places. So vowel A and E can arrange either second or fourth. So in 2 factorial, like and are things to arrange, are things to be arranged at R places. R factorial is the number of A's. Oh, same formula they have applied. Consonant letters B and L can be arranged on first and third place. So again, 2 places, 2 things to be arranged. So 2 factorial. They are both dependent events. So total ways of arrangement 2 into 2. Is that clear, everyone? Any doubts? If there is any, please ask.
No, sir.
Are you enjoying this chapter, PNC?
Yes, sir.
Okay. Next question. In how many ways can a team of 5 players be selected? In कौन से sports में 5 player होते हैं? Anyone? In which sport there is a team of 5 players? Let me see if you're awake or not, or aware or not about sports. Who plays basketball? Karini, Gurucharan. Any one of you?
No, sir.
No?
No, I don't know about basketball actually.
There are 5 playing players in basketball. And yes, in how many ways can a team of 5 players be selected out from 8 players so as to not include a particular player? So we have total 8 choices and we have to make a team of 5 and it is given that we do not have to consider a certain player. Okay, so if we do not have to consider that, so our total number of choice now becomes 7. So out of 7 we have to select 5 players. Is that clear, everyone? It's not rocket science to understand, right?
Yes.
Clear?
Yes, sir.
Okay. So now we have to make 5 selections out of 7. 7c5, right? 7 factorial upon 7 minus 5, 2 factorial into 5 factorial. 5 factorial cancel 7 by 7 into 6. 2 cancels 6 by 3. 7 into 3 becomes 21. There are 21 ways to make a team of 5. Given that there are 8 players, but we have to make only choice out from 7 players. Cool. Clear, everyone? Is that clear?
Yes, sir.
So NCR is basically the number of ways of selecting R elements from N. And the formula is N factorial upon N minus R factorial into R factorial. Is that correct now? How many 5-digit prime numbers can be formed using the digits 1, 2, 3, 4, 5 if the repetition of digits is not allowed? So 5-digit prime number. For prime numbers, we do not have any exact condition that for, let's say, if we had to make any number which is divisible by 3. So what would we have done? We have summed all the digits and applied the divisibility rule of 3. If we had to make any numbers getting divisible properly by 2. So we'll make an even number and we'll only fill 0, 2, 4, 6, 8 on this place. But in the same scenario, we will have to ensure that there is prime numbers. So first let's consider we have 1, 2, 3, 4 as our digits to make a prime number. Let's first check their eligibility. So after reading this question, nothing comes to my mind except there is a special option here. Are we able, will we even able to make any prime number out of using these digits? Let's discuss why. Can anyone tell me what is the divisibility rule of 3? Like we know, the only even prime number is 2. So there is no even prime number of 5 digits. So 2, 4 should not come here. Okay, so that's about the condition of not getting divisible by 2. Now let's check for 3. The divisibility of rule 3 says that sum all the digits and divide them by 3. If the remainder, if it is properly divisible, then it's divisible by 3 also. So let's sum all the digits. We are definitely aware that these 5 digits are only going to come. They may have different positions like 5, 4 here, 3 here, 2 here, 1 here. But these only digits will be used. Okay, so let's sum them. What is their sum? 3, 3, 6, 6 and 9, 15, which is divisible by 3. So हम कुछ भी कर लें, whatever we do, however we arrange these 5 digits, they are definitely going to be divisible by 3. If any particular number is divisible by 3, then it's not a prime. Definitely not a prime number because it's a 5-digit number. It's not 3. We can say that 3 is a prime number. It's divisible by 1 and 3, but only 1 and 3. This is a 5-digit number and this is also divisible by, let's say the 5-digit number is this. This is divisible by 1, 3 and the 5 and the number itself. So there are more than 2 factors here. So hence we will not be able to make any prime number. So there are 0 prime numbers that we can make. Let's read the explanation. Any 5-digit number found by the digit 1, 2, 3, 4, 5 without repetition will be always divisible by number 3 because the sum of digits of any number thus form 1 plus 2 plus 3 plus 4 plus 5, 15 is divisible by 3. Hence, prime number of 5 digits cannot be obtained by using the digits 1, 2, 3, 4 and 5. Is that clear, everyone? If there is any doubt, please ask. I assume no doubts. Okay, then let's move ahead. A polygon has 44 diagonals. Another previous year question on same concept. A polygon has 44 diagonals. The number of its sides is. So for finding out the number of diagonals, we have formula NC2 minus N is equals to 44. Okay, we have to find the number of sides. Cool. So NC2 is n factorial upon n minus 2 factorial into 2 factorial minus n is equals to 40. This cancels this by n to n minus 1. Taking n common, n minus 1 by 2 minus of 1 is equals to 44. N into n minus 1 minus of 2 divided by 2 is equals to 44. So n into n minus 3 divided by 2 is 44. N into n minus of 3 is equals to 44 into 2, that is 8. Now let's substitute the value of n from the options. Assuming option number A has to be true, 11 into 11 minus 3, 8 has to be 88. And that is precisely happened. So our hit is successful for in the first time. Hunt, we have achieved the hunt. We have hunted the prey. Option number A is correct answer. Any doubts? Any doubts, or are you slept?
No, no doubt, sir.
Okay. The number of ways in which 3 holiday tickets can be given to 20 employees of an organization if each employee is eligible for any one or more of the tickets. So it's like kind of an independent event. It doesn't matter. Uh, okay. So how many tickets we have? 1, 2, and 3. These are fixed places which has to be allotted to some member. Okay. So we can repeat basically any member can have any one or more tickets. Okay. So for the first ticket, how many choices we have? We have 20 choices, 20%. Now for the second ticket also 20 choices. Why? Because one person can get more than one ticket. Okay, so 20 choices for second place also, 20 choices for third ticket also. 20, 20, 20, make it 8, 3 zeros. Answer. Any doubt, anyone? Tickets has to be given, that was sure. Okay, this is ticket number 1, this is ticket number 2, ticket number 3. But to whom it is given, that is the number of way. How many choices for the first ticket? 20 choices. Second ticket, 20 choices also, because the person who has got the ticket can also get one more ticket. It was given in the question. Now is that clear? And if you are having anyone if you guys are having dinner, if you're not able to unmute yourself, then I'll stop asking. You please inform me once. Okay. Each employee is eligible for one more ticket. So this is the next questions. Very important. Out of 15 points in a plane, okay, n points are in the same straight line. Okay, there are n points in a same straight line. 440, okay, out of 15 points. So, and 15 minus n points are not on the straight line as per the given conditions. There are some 15 minus n points which are not on the straight line. Total number of triangles that can be found by using these points is 445. 445. Okay, so you tell me, for making any triangle, we have to make sure that we either take 2 points from here, or 1 point over here, or 0 point from here. Okay, we cannot take 3 points from n. Cool. Let's assume that we are taking 2 points from n. So selecting 2 points from n and selecting 1 point from the outer. ठीक है, यहाँ से. So 15 minus n C of 1. Plus we can select 1 point from here and 2 points from here. Plus we can select no point from the first and C0 and select all 3 points from here because they are not given as collinear. Okay, so 15 minus of n, selecting all 3 points from outside of the straight. Cool. So now we have equation with a single variable. We'll be able to solve. If the god of calculations is with us, then the grace of him. Okay, 445 is equals to NC2 can be expanded as. So instead of we had to find out the value of n, na? So let's just try to eliminate and hit and trial at the starting only. Or should we like expand it and then hit and trial? What do you think? I think we should go with the first. Well, let's hit and try now only. So let's try the options here. 3, 4, 5, 6. This is A option, B option, C option, D option. I feel the most convenient option is to go with C because there's a 15 here and there's a 5 here. So with 10, I think we'll be able to solve the question fastly. And also 445 is kind of the factor of 5 because the law of symmetry is attracting like that. I'm surely, I'm honestly saying I do not know the answer. Let's go with 5 first, option number C first. If we will fail, we'll start from the option number A. 5 C2. So 5 factorial, 3 factorial, 2 factorial, 15 minus n, 10 factorial, 10 minus 1, 9 factorial, and 1 factorial, plus, and we know NC of 1 is n only, basically. Let me prove that. This cancels, this becomes n only. Okay, and NC of 0 is n factorial. Cool. So just let me write here 15 minus n only. That is basically 10. Plus NC1 is n only, which we are considering as 5 in this case. Into 15 minus n, so that's 10 factorial. 10 minus 2, 8 factorial, 2 factorial. Plus NC0 is basically n factorial, that is 5 factorial. Into 15 minus n factorial, that is 15 minus 5, 10 factorial. 3 cancels this by into 5 into 4. 2 cancels this by 2. Okay. 100 into 100. That way this become. So 10 into 10 becomes 100. This cancels this by 10 into 9. 2 cancels this. 25 into 9 is basically 125. Yes, I am right, I guess. No, 225. 5 factorial is 120. 10 factorial is, my god, out of our limit. Oh, there is a 3 here. That's why. That's why. Otherwise, this would have been a very big term. NC0 basically. So basically 5C0 is 5 factorial. 10 fact. This has become 10C3. 10 factorial upon 7 factorial into 3 factorial. Let's cancel this with 10 into 9 into 8. 3 factorial cancels it with this is 6 basically. So 3 2s are 6, 3 3s are 9. 2 cancels this with 5. 15 into 8 is 120. 5 factorial is also 120. Are we correct? Are we going right? I guess so. I guess so. I guess so. NC0 is n factorial to n minus 0 factorial into 0 factorial. Oh my god, that is one. That is one, ladies and gentlemen. NC0 is 1. N factorial upon n minus 0 factorial into 0 factorial. So that should be 1 here. And okay, else we have not done the same mistake anymore. Let's find out the sum. 335, sorry, 325 plus 100 plus 120, sorry, 120. So 5, 2, 2, 4, 3, 1, 4. Yes. LHS is equals to RHS. And let's check the answer. Yes, C is the correct answer. Now you will ask me that, sir, you must have known this answer. That's why you have gone with C option first. But I'm damn sure I did not. Even if you, so see what trick I applied here. I just observed the numbers. There's a factor of 3 and 5. Here it would be very convenient for us if we take n is first to 5. Okay, that's why only there is a mathematical feel, intuitive nature kind of. You just see numbers and you can guess sometimes. Okay, otherwise for you it would have been taken a longer time after checking option number A and B. Then you would also have solved the same. Clear? Any doubts? Any doubts? Basically, after this solving this equation, there is only calculation. You have to do it smartly. The concept was that we did not have to take all 3 points from a straight line. We can take 0, 1, or 2. And with 2, we have to take 1 point from here. With 1 point, we have to take 2 points from here. With 0 point there, we have to take 3 points here to make a triangle. Logical enough? Right. Okay. The next question asks the number of different words, 8-letter word, ending and beginning. Okay, 8-letter word. 4. Okay, 8-letter word, ending and beginning with consonant. Ending and beginning with consonant, which can be made out of the letters of the word equation. So let's write all the consonants. Spelling of consonant is right. Q is a consonant, T is a consonant, and N is a consonant. Only 3. And U is a vowel, A is a vowel, I is a vowel, O is a vowel, E is a vowel. So 5 vowels, 3 consonants. So how many choices here? 3. After using one choice, we are left with 2 choices. Then we are left with 5 vowels and 1 consonant as a choice. 6 choices here, 5 here, 4 here, 3 here, 2 here, 1 here. So 6 factorial into 3 into 2. That is 6 into 6 factorial. Now 6 factorial is 720. So 0, 2, 6, 12, 1 carry, 4 and 4320. B option should be the correct answer. Any doubt? Is there any doubt? The basic concept, steps to follow in these kind of questions, we have to fill those places who have a condition on them. So we'll have to consider the special cases first, thereafter fill the remaining with whatever left to us. Clear?
Yes, sir.
There's a particular way to solve these questions. That's why in this chapter, there's not much concept, but there's application to be taught. Yes, clear. Next question. How many different permutations can be made out of the letters of the word permutation? Okay, cool. So we have to find how many number of ways are to arrange this particular word. So let's assume this first. Let's observe this first. So how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Is that correct? 11 letters are there to be play to be arranged on 11 places. So 11 factorial. Is there any repetition? P is getting repeated? No. E is getting repeated? No. Is R getting repeated? No. Is M getting repeated? No. Is U getting repeated? No. Is T getting repeated? Yes. How many times? Twice. So we'll divide it by 2 factorial. Is A getting repeated? No. Is T? Yes, we have already talked about it. Is I getting repeated? No. Is O getting repeated? Is O getting repeated? No. Is N? No. 11 factorial by 2 factorial should be our answer. Now we know about 11 can get expanded like this. 7 into 6 factorial, we are aware about 6 factorial, so let me write it. 2, 2 cancels 8 by 4. Now we have to do a calculation. This becomes 36 and this becomes 77, and considering this will make it a 770. This will become 36. This is 720 itself. So let's now multiply 770, 720. Let's take these two zeros at the end and write two zeros बाद में. 77 into 2 is basically 154. 77 4 and basically this is 539. 4 594, 1 carries 5 5 2 zeros, okay, and it is getting further multiplied by 36. We have multiplied these and got 5540440. Now 36 is also getting multiplied 55440. Let's leave those double zeros and we'll write it after solving. 6 into 4, okay. Just after writing this question, this here, I'm looking at the options. After two zeros, there are two zeros in every option. Okay. The unit place should have 4. Here it is not. Here it is not. Now we'll look for the two options. 6 into 4, 2 carries. 6 into 4, 6. 2 carries. Okay, we don't care about others. 3 into 4, 12. This will make 4 and this will make it a 8. Now here should be 8, not 2. B, C option is eliminated, and hence with good luck and good presence of mind, I was not, मुझे पूरा क्वेश्चन सोल्व नहीं करना पड़ा. I didn't had to solve all of the calculation, right? Let's check our answer. Yes, yes, yes. A is the correct option. A is the correct option. That's how you can calculate mindfully by looking for at the unit digits. Right, that's why I was teaching you the basics at the first. Is that clear, everyone?
Yes, sir.
Nice. Let's go ahead. Do you guys need a break? No, because there are no breaks involved. If you need it, no problem.
No, sir.
Okay. So let's jump on to the next question. A tea party is arranged for 16 people along two sides of a long table. So there's a long table like this, and there's a tea party for 16 people, 16 people. Along two sides of a long table with 8 chairs on each side. So 8 chairs on each sides. How many chairs? Four and four chairs. Not one, two, three. Okay, 16 chairs on both of the sides. Four particular men, four particular men wish to sit on a one particular side. Out of this 16, four will definitely sit on one side with like them sharing a side. Okay, so let's assume in a scenario we are sending four people on one side. So while choosing, we can either send them on the left side or the right side. Let's assume first scenario. We are choosing sending the four persons here, four men here. Okay. Two particular men wish to sit on the other side of these two. Okay. So naturally these two will be going here. The number of ways that they can be seated. Now, after first we need to make a choice of whether sending these four people to the left or to the right. So we are assuming one scenario in which we have said send these four people on to the left. So after sending on to the left, we can arrange them in 4 factorial manner. Sorry, there are 8 chairs and 4 people needed to be set. They can select 8 chairs in how many ways, and how many ways they can arrange themselves is 8p4. 8 chairs, 4 men, they can arrange themselves in this manner. What about other person? 2 persons are sent onto the other side. So out of 8 chairs, they need to select 2 chairs, and they can arrange themselves on those 2 chairs. Okay, so we have now talked about 6 persons. We had total 16 persons. How many are left? 10 are left. And they do not have any objection to sit on any side. So all, let's say, these 4 are booked here and these 2 are booked. Now 10 persons are remaining and 10 seats are remaining, and they don't care about whether on which side they have to sit. So we can just arrange them on 10 people on 10 seats, 10 factorial, basic. Now this is about when those 4 people decided to sit on the left side of the table. What if they choose to sit on the right side? Then also similarly, they'll have 8 vacant chairs to choose and arrange themselves for, and those 2 persons will now go to the left hand side. So this is with respect to 4 persons. Now those remaining 2 will sit on the other side, and there will be 8 empty chairs. They can select any 2, and also the remaining person can arrange themselves. So these are 2 scenarios, independent both times. So if they are independent, we can add them. If they are same, we can definitely write 2 in the multiple and then solve. Is that clear? How have I written so? Clear or not?
Yeah, clear, sir.
I have added the same terms, that's why we can write 2 here. And also, why particularly 8p4? P represents that selecting 4 things, 4 chairs, and arranging, selecting 4 chairs out of 8 and arranging 4 people on them. Good, clear. And if it is happening on the left side, on right side, the other 2 will go and will select 2 chairs out of 8 and will arrange themselves. The remaining just don't care. They will sit on any on chairs wherever they are. So they will arrange themselves for sure after selecting. Okay. They are not choosy person, simple, sober. Okay. So let's now solve them further. 2 into. Now also look at the options. there is 8 factorial available. We are certainly going on the right lines. So 8p4 is 8 factorial upon 8 minus r factorial, that is 4 factorial here. 8 minus 4 is a 4 factorial. Okay, let me do it on the next page. N factorial upon n minus r factorial into n factorial upon n minus r factorial into 10 factorial. So now we have 8 factorial into 8 factorial in the options as well. So with this hope that it may become our answer, will not do anything with these two particular terms now. We are only going to cut these denominators with the other ones. So 10 factorial can go cancelled by 6 and 10 will become 10 into 9 into 8 into 7. 6 factorial is also got cancelled, has already got cancelled. 4 factorial is basically 24. 2 cancels 24 by 12 and let's do something here. Then 12 by 2, 6, 10 by 2, 5, 6 by 3, 2, 9 by 3, 3. 2 cancels 8 by 4. 5 into 3 into 4 into 7. 5 into 4 is 20. 20 into 3 is 60. 60 into 7 is 420 into 8 factorial into 8 factorial, which is matching with our option number. No option. Have you done any mistake? 5 into 4 is 20. 20 into 3 is 60. 60 into 7 is 420. I'm very sure that we have done some mistake because it's not matching with our answer. 2 into 8 factorial upon 4 factorial into 8 factorial upon 6 factorial into 10. 6 factorial cancels 8 factorial by 10 into 9 into 8 into 7. And divided by 24. 2 cancels 24 by 12. Now, here what was there? 10 into 9 into 8 into 7 divided by 12 into 8 factorial into 8 factorial. Okay, so 9 into 8 is basically 72. 12 cancels 72 by 6. 16 into 7. Okay, we are indeed right. We're just getting confused. So there must be some different answer. This is not 16 factorial. Now we'll have to solve this particular whole thing and then this is 8 factorial ka cube, I guess. Is it? No, this is 81, I guess. Okay, what is 81 square? This question is becoming tedious now. 81 into 8 into 64, 648. Hello, 648, 1886, carry 6561. Okay, 6561, 6561 into 81. Let me save the file first. Uh, 6561 into 81, 8, 8 6 are 48, 4 carries. Once again, 4 carries. 52. Okay, 186, 86, 86, 14. What I'm doing? 8 6 14, 1 carries. 8 5 13, 14, 1 carries. 1 carries. 5 3 1 4 4. Okay, so this is 81 cube basically. Now let's check with our option. 420 into 8 factorial into 8 factorial. What is 8 factorial? 8 into 7 into 720. And once again 8 factorial, 8 into 7 into 7. Okay, what was given to us? 81, 81 into 81. Let's try to break it. But in 8, there is no prime factor of 7 involved. Here, 7 into 60 is involved. So definitely, C is not going to become our answer. Yeah. Let's check about. We have already checked about option number C and A. So I'm going and gambling for option number D. That it should be a correct answer. Okay. But option number C is only. Yes, we haven't done any mistake because we were close. We have definitely made any mistake. The answer is coming as 420 to 8 factorial into 8 factorial. Here they have not considered 2. Like there was a table sitting on this side or this side, doesn't matter to them. I guess so. That's why they have not taken 2 in the multiplication. Otherwise, all our calculation is exactly the same, but they have not chosen and they have not taken consideration whether going for the left side first or the right side first. Okay, if that is so, but I still have a confusion because there is always lack of clarity here. But it's the answer key is always right. The teacher may have confusion, so you shall go with the book only. A tea party is arranged. So basically, whatever we have just discussed earlier here, here, everything is same instead of considering sending them left to right. And now I'm not saying that what we have done is wrong. No, actually, what we have done is not even taken in consideration. That didn't matter to the question maker and the examinee whether the 4 persons sit on the left side of the table or the right side of the table. He has taken it as a symmetry. It doesn't matter to him. Something like this. And then only this is basically 8p4 and this is 8p2. So here multiply 8p4 into 8p2 into 10 factorial and solve for the answer. Is that clear, everyone? Why our answers are mismatching? Any doubt?
No, sir.
I'm still having doubts because I have explained it. Now it must be first to like understand the method that I've told. Then I'm saying no, it's wrong. It's otherwise. But that the particular fact that we were assuming that it must be a difference for sending these 4 people first to the left or to the right is not even taken into consideration by examiner. So that's why our answers are different. That's why they have not added both of them and multiplied it with 2. That's why our answer was basically 420 into 8 factorial square. But the answer is 210, the half of it, only because of this. Is this clear now? No? Should I repeat? Hello, hello. Should I repeat?
Sir, could you repeat again? It's a bit confusing.
Okay. Let me repeat again then. So we'll read question again, once again. Okay, so here's the question. A tea party is arranged for 16 people. Two sides of a long table with eight chairs on each sides. So this is a long table and there are eight chairs. So let me draw a chair first. And I'm very dedicated to make that. How should we make a chair? Array. So yes, it's a chair finally. It's a chair. One chair is this. Okay. There are eight similar chairs uh, that are there placed. Four chairs are these. But you have to place eight chairs. Eight chairs and eight chairs on the other side also. Okay. How is my drawing? Fine. Okay. 16 chairs. There are 16 people, eight chairs on both of the side. 16 chairs are there. Four particular men wish to sit on one particular side. So there are 16 people. And out of these 16, four people want to sit on a particular side, and the other two, they want to sit on the other side of these four two, against these four two. Against these four people. So let's go with the first condition. Let's make the first four-person sit. They have gone to any side, and now they have chosen four seats. So in a side there are eight seats. So for them to select four seats out of eight, now they are selecting four seats out of eight, and they will be also arranging themselves. Like say A, B, C, D are there after selecting four chairs, four places. So how many choices here? Four choices, three choices, two choices. So that's why we'll taking permutation here. Note that combination. In combination, we just select. In permutation, we select and arrange also. That's why 8p4. Okay. If 8p4 are the choices available with these four people, how many choices are available with these two? Of course, they will be going to the other side now. Now on the other side, all eight chairs are vacants. So they'll have to select and arrange themselves on two places out of eight. This is, we have talked about these four people and two people. How many are left? 10. How many seats are occupied? 4 and 2, 6. So how many seats are remaining? 10. 10 seats are remaining. 10 persons are there. So 10p10 is 10 factorial. Okay, we'll multiply them all now because they are dependent case. They are sitting on the same table. Is that clear till now? With such a good drawing? Clear or not?
Clear, sir.
Okay. So now the total number of ways to set all these 16% is to, like, we will multiply with whole 8p4 into 8p2 into 10 factorial. Okay, let's solve this on the next page for better clarity, or we can also do it here. 8p4 is 8 factorial upon 8 minus 4 factorial is 4. 8p2 is 8 factorial upon 6 factorial into 10 factorial. 10 factorial expands as 10 into 9 into 8 into 7 into 6 factorial. We are not going to touch 8 factorials here because they are there in the option. So 6 factorial cancel 6 factorial. 4 factorial will become 24. Now 8 cancels 24 by 3. 3 cancels 9 by 3. So this becomes 8 fact, right here. 8 factorial square into 10 into 3, 30 into 7. 30 into 7, that is 210. So basically option number C is the correct answer. Is that clear, everyone? Now, clear?
Yes, sir.
49. Let's go to the next question. Are there any questions left? Oh, I am lucky we have. How many numbers between 100 and 1000 can be formed with the digits 5, 6, 7, 8, 9? If the repetition of digits is not allowed. So between 100 and 1000. So basically from 101 to 999. We can, where 101 and 999 are inclusive. So basically we have to make 3-digit number in this range. We have only, we don't have only all the digits. We have only these 5, 6, 7, 8, 9. So 5 digits, we have 5 choices. So can we fill any of the choice at this hundreds place? If we fill 5, it will be like all the numbers with 5, any digit here or any digit here is in the range here. Okay, so we can fill 5. 5 is correct. 6 also, 7 also, 8 also, 9 also. Because when we will use 9 here, whatever you use here, 8, 7, 7, 8, it's not going to become more than 999. And even it's not going to become 999 because we cannot use 9 multiple of number of times. So how many choices here to fill this place? 5. After using 5 choice, after having used 1 choice for 1 place, 4 choice for here, 3 choice for here. Let's multiply 5 into 4 into 3, 60 should be our answer. Is that clear, everyone? Now, this range was given to us just to give a reference that there will be 3 digits number, and that should be in this particular range. We would have only considered it but in this scenario, there is no chance to go out of range. So we just go on a full throttle, and we didn't care about this range because using any of the number on 3 places will make us land in this big range. That is all. Clear? Any doubt?
No, sir.
Okay then. See, numbers between 100 and 1000 are 3-digit numbers. It is given that the digits should not be repeated. So number of given digits choices are 5. In a 3-digit number, first number can be arranged in 5 ways, second number in 4 ways, third number in 3 ways. 5 into 4 into 3, 60 is our answer. Next question is, how many 4 digits number are divisible by 10 that can be formed using digits 1, 5, 0, 6, 7 without repetition of digits? Now, please tell me what is the divisibility rule of 10, or how should we check whether any number is divisible by 10 or 100 or 1000? Tell me. Please respond fast. Now, how should we check? Like, if there is any number ending with a zero, then it's divisible by 10. If there is a number ending with 20, then it's divisible by 100. Ending with three zeros, divisible by 1000. Similarly, so if we have to make this particular 3 or 4 digit number divisible by 10, we'll have to use a 0 digit here, which is also available in our domain, which is also available for us to use. So having used one choice out of given 5 choices, we have now 4 choices left. Okay, 4 choices for this place, 3 choices, 2 choices remaining. And here 0 is there, so only one choice is here. Now 0 is the element. So I should write 0 down for better representation purposes here as 0. So one choice is only. 4 ways, 3 ways, 2 ways, 1 ways. All events are dependent. 4 into 3 into 2 into 1, that is 20. A should be our answer. Any doubt, anyone? Is there any doubt? No doubt? Okay. Then next question. 3 dice having digits 1, 2, 3, 4, 5, 6 on their faces for sure are marked as 1, 2, 3 and are rolled. Let X, Y, Z be the represent the number on die 1, die 2 or dice 3 respectively. What is the number of possible outcomes when this is a condition that the number that is there on the first dice should be greater than the second and that should be greater than the third? So for any particular dice, there are possibilities of giving a number 1, 2, 3, 4, 5, 6. But so for solving this particular question, we'll have to make a table. So for the first dice, second dice, and third dice, so we'll start from filling the third dice first, because it should be having the smallest number. If there is 1 here, so there can be 2, there can be 3 here. There can also be 3 here, and there can also be 4 here. There can also be 4 here, 5 here. And with 2, so let me, instead of writing like this, let me write in some other manner. With 1 here, how many numbers can be here? 2, 3, 4, 5, and not 6. Okay. With 2 being here, will take us time. Let us start from where. With 6 being here, how many numbers can be here? 5, 4, 3, 2, or 1. Or instead of writing like this, we will write in column manner 5 or 4 or 3 or 2 or 1. Which numbers can we place here? Here can be 4, 3, 2, 1. Any number? 3, 2, 1. Any number? How many numbers here? 2, 1. How many numbers here? And this case will not just happen because there is no number less than 1. So this is about dice number 1, dice number 2, dice number 3. If there is a outcome like 4 here, so how many numbers can we add there at this in this on second dice? 4, 3, 2, 1. With 4, there can be 3 and 2 and 1 possible outcomes. With 3, 2 and 1, with 2, 1 and 1 will not exist because there's nothing less than 1. Similarly for 4, so let's instead of writing about everything, let's observe a pattern here, and maybe we can conclude something about regarding that. So if there are 6 outcomes, if there is an outcome here in the device first and the dice first, so there are 4 outcomes possible here, and particularly here 1 plus 2 plus 3 plus 4, these many cases available. So 1 plus 2 plus 3 plus 4. For fifth, this was for 6 on first dice. For 5 on first dice, how many cases? 3 here. So I'm assuming 1 plus 2 plus 3 cases here only. For 4 on the dice first, 1 and 2 only cases here. For 3 on the dice, 1. Then only 1 case. Why? If there is like let me write the condition again. That the outcome on device dice first should be greater than second, and second should be greater than 3. Now, similarly, if we write 3 here, then the only small number is 2 or 1. Less than 2 is only 1. There's nothing less than 1, so this scenario will not be. There will be only one case where 3 is on the first dice, 2 is on the second dice, 1 is on the third dice, with 3 be on the first dice. So that's how we have calculated all the numbers of cases. So this is basically 6 plus 3, 9 plus 4, 13. 6, 3 plus 3, 6. 1 plus 2, 3. So this is 1 only. This becomes 4, 4, 6, 10. 10 and 13. Sorry, 10 and 13 becomes 23. I'm doubting. 3 and 3 becomes 6. 6 plus 4, this becomes 10, not 13. So 10 plus 10, that becomes 20. And these should be your answers. And if I were not able to explain you well, this is the well table here. That the basic condition was that the dice number 1 should have greater respond than the second or first. So they have started with, if say there is 1 respond, there is 1 number on the first dice, then there can be 2 here, 3 here, 4 here, 5. There's 2 here, there can be 3, 4, 5, 6. There's 3, 4, 5, 6, 5, 5, 6, and 5, then 6. How many cases are here? This is the first case. Okay. This is the second case. Sorry. How many cases? 1, 2, and 3. One case. 1, 2, and 4. Other case. 1, 2, and 5. Third case. 1, 2, and 6. 4 case. So 4 case here. 3 case here. 2 case here. And 1 case here. That's total number of ways, with 1 being on the first, on the third dice is 10. So they have solved like this. And from here you can also see and understand this. Is that clear, or should I explain more? Is that clear?
Yes, sir.
Okay. There's one more question. Let's solve it. How many 3-digit even numbers? So 3-digit even number should have here with the digits 1, 2, 3, 4, 5. So even numbers should be used here. 2 and 4, how many choices? 2. When repetition of digits is not allowed, 5 choices we had, out of which one we have used. 4, 3 are the choices available here. 4 into 3 into 2. 4 into 3 is 12, into 2 is basically 24. C should be our answer. Is that clear, everyone? Okay. Why it is wrong, yaar? How many choices we had? 1, 2, 3, 4, 5. Hmm. Okay, how many three digits? Even number. How many choices for the unit digit? 2 only. 2 and 4. Okay, 2 choices here. And we had total 5 choices. We have used 1, 4 and 3. We had total 5 choices. After using 1 choice, we are left with 4 choices, then 4 into 3 into 2. So that should be correct. No, the answer is wrong. I definitely challenge this is wrong. Answer should be 24 only. It should be 24 only. Why it is wrong? Because they have chosen just selection. But arrangement also matters in number. Like 2, 6, 2, 4, 2 and 4, 2, 2 is not the same number. Arrangement also matters in case of numbers. It's a wrong answer. Let's check if there's any other question now. And if I'm wrong here, I'll definitely let you know later on, but I will challenge this answer and see is the correct option. Is there any doubt?
No,
Is there
sir.
any doubt? Okay, if there's not any, let's conclude the class. Thank you.